plus
e to x. Yep.
Plus 10.
Awesome. Perfect. So f average on the interval 3 comma 5 will be 1 over 5 minus 3, the integral from 3 to 5, from e to 2x plus 10 dx. Perfect. 1/2 in front. Which function prime is e to 2x? We established that there is no need for substitution here. We have a quick answer for that.
Is it e to 2x?
Nope, because when you differentiate this, you have to get e to 2x.
E to the 2x over 2.
That's it. Plus 10x from 3 to 5. So let's establish this again. When I differentiate this, I get e to 2x times 2, which simplifies with a 2 in the denominator, and that's how I get e to 2x. Is that okay, everyone?
Yes.
Perfect. Okay, then, so all I have to do is plug in 5, keep the 1/2 outside. So this is e to the 10th over 2 plus 50 minus
How did you get the 1/2 again? Is that just standard 1/2 out front?
So the formula on a comma b is 1 over b minus a, b minus a, the integral from a to b from f of x dx. So 5 minus 3.
That makes sense now, yeah.
Okay, very good. So minus e to the 6 divided by 2 and minus 30. Please remember when you plug in 3, both terms have to be subtracted. And whatever the problem is asking us, we will plug it in and get an approximation. Good. Okay. Do we have to practice the linear regression line?
Is that the one on the calculator?
Yes.
Okay. Could we just go over one problem?
Yes.
I got kind of confused with like sometimes like it would be like it would start with like 2014 and it would just be 0 and then it's like find 2024 or something like that.
Because you have to find the regression line first, right? So
yeah, I got that part, but just like sometimes like the numbers like didn't add up. It was in like my math labs, some of them.
Yeah, let's choose one. Do you have one from my lab math? That's fine.
I can go find one.
Yeah, awesome. If you want to share your screen, let's find any. Awesome. Well done. That's the easiest thing for me when students choose problems. That's the best. No, I'm not lazy when it comes to choosing problems, but I love to see what you come up with, what you need. Okay, so we have 0, 2, 3, 4, 5, and we have 8, and we have 9, we have 950, we have 1050, and we have 12. That's it. Oh, okay, so around the predict, okay, and predict for 2022, that's the next question, and number of years since 2014. So this is since 2014, and the estimate from the regression line for 2024. Okay, that's it. So you don't have to, you can stop sharing. Okay, so first of all, we are given the information, the ordered pairs. So I'm going to share my screen and then put them in the graphing calculator. We go to lists, we go to edit, clear the lists that you have. They're not useful anymore. Or you can just move on to the list 3 and 4. If you want to keep what you have in list L1 and L2, you're free to do so. Okay, so I have 0. I have 2, 3, 4, 5. 2, 3, 4, and 5. And then the corresponding ones in the exact order we see them here. They have to be paired correctly. 9.5, 10.5, and 12. Now, I prefer to see what this is what's happening here. So it's between 0 and 5 and between 8 and 12. So I go to the viewing window. Let me see if I still have that. Yes, I do have the plot highlighted. And then I go to the viewing window and I will pick between, let's say, -5 and 10 for the x with a scale of 1. And y minimum, it goes from 8 to 12. I'm going to say, I want to see the y axis. So I'm going to say between -2 and 15, that's okay, with a scale of 2 or 3, doesn't matter. And I want to see my plots, the ordered pairs, 0, 8, 2, 9, and so on and so forth. Okay. Okay. So I may be interested in looking at quadratic regression, or I may be, depending on, it's hard to, having only 4 ordered pairs is not enough to draw a conclusion. But I'm assuming they're asking us the linear regression. Is that what they're asking? I didn't read the whole thing. So I saw the points, and now I go directly to stats and calculations, and I go to number 4, the linear regression. And I want the x list is L1. The frequency or the y variable is list L2. And I want to calculate. That's not what I want to do. It didn't select 4, I just realized. Or I did not select 4. Okay, list L1, list L2. I don't want anything here. And I want to store the regression line so I don't have to type it in myself. I'm not lazy, but the feature is there. Why not use it? So we go to variables, and I want variable y1 to be where the calculator puts the function in, the linear regression line. And then I want to calculate. So I got the linear regression line, and this is the slope, mx plus b. The slope is 0.7635, and the y-intercept is 7.6622. So I'm going to write now y equals 0.7635x plus 7.6622. You do not need the correlation coefficient or the determination coefficient, the coefficient of determination. You only need A and B. So now I want to graph again, because when I graph again, the calculator will graph those 4 points again, 5, forgive me, those 5 points again, plus the regression line. Okay? So this line is the line of best fit. It's the line that best fits the information. A line cannot go through these 5 points. That's not possible. It may not even go through any of them, but it's definitely having the smallest amount of error. We call it residuals. Okay, now I'm also asked to determine what happens in 2024 and 2022. All I have to do, I'm going to stop sharing for a second, I'll come back to this. So 2022 is 8 years away from 2014. So then this will be basically 8, and I want to determine the estimate. This will not be the exact, but it will be the estimate through the linear regression line. And then this one is for 10 years. So this will be 10 and whatever. Now, if you remember, I said this last time. If we are looking at the range between 2014, because that's what it says, so this is the year 2014, plus 5 years, which is 2019, these two may be out of range, and they're not here, right? They're outside. Now, if somebody tells us it's okay to estimate these because this pattern will continue, then it's okay. But if there is no guarantee that the pattern continues, I cannot fully and with no error, right, estimate outside of this. So this line was determined with these points. I don't know what happens here or after. Maybe this changes. But I will estimate using 8 and 10. So all I have to do is go to the table, plug in 8, plug in 10, and get the y value. But again, remember, this is where the data is. We do not want to go too far out because there is no guarantee that the model continues. Okay, so keeping that in mind, the line is already there because I put it in. So I go to second and table. All I have to put in is 8 and 10. So go back and highlight just in case, but we are using 2 decimal digits anyway. So the first one is 13.77. And the other one is 15.3. So these are our estimates. We should not carve them in stone and say this is it, because unless we are told, hey, listen, this model will continue. So that was the linear regression line. I would feel so much better if you would ask me to evaluate for 1, in other words, in 2015. But if you say evaluate 20 years later, I'll say, oh, no, I don't know. I don't know if this continues to be true. Good. So this was the linear regression line. So what is left? Maybe indefinite integrals or definite integrals and substitution. The areas enclosed by graphs. This is how to evaluate an integral that was given into 2 pieces. Differential equations, consumer surplus and producer surplus. What are we continuing with? Anyone would like to choose the next topic?
Can we do indefinite integrals and substitution?
Yes. So please choose from section 4.5. Indefinite or indefinite, definite or indefinite, whatever you want. And I'll tell you the page number. Page number 434. So page 434. I'll open. I don't think I ever got into the book to open anything. So 434. And before I forget again, I'm kindly asking you to fill out the student opinion form. Do you know where it is, where the assignment is for extra credit? If you don't know, please let me know and I'll show it right now. So we want 434. Okay, it doesn't want to. Okay, it does. So you can choose anything you like from here. Definite or indefinite.
Would you 52?
Yes, 52. Here it is.
And then 56.
52 and 56. Which page am I on? I'm on page 5. So we said 52 and 56. Let's start with 52. So the integral from 1 to 4 from 2x plus 1 over x squared plus x minus 1 dx, of course. Good. So where do we look? where do we look at this function? This is the function, this is the x, and this is the integral from 1 to 4. Where do we look? Do we look at the numerator or the denominator? Yes, the denominator is the problem. Awesome. So can I get rid of it somehow? Only if du is in the problem. If du is not in the problem, minus a constant, then it's not the right path. What is going on here?
Will it be 2x plus 1?
No.
Dx.
Yes. Please remember du is not f prime. Du is f prime times dx. So I like that. So from here, do not copy the limits of integration, please. So what do we write?
du over u.
Yes. And now carefully let's determine the limits of integration. When x is 1, what is the lower limit for u?
1,
Yes. Very good. When x is 4,
19.
so 16, 20, 19. Awesome. Excellent. Now, which function prime is 1 over u?
ln of u.
Please remember, it's not ln u, but absolute value. Good. And now what do I write? You could say, and the argument is correct. Well, but these are positive values. You don't need the absolute value. True, but the correct step is natural log of the absolute value of u. So then what do I do?
We have to plug in ln of absolute 19 and then minus 1. Ln of 1.
Okay, how much is ln of 1?
Is it 1?
Careful. If you ever forget, just plug it in your calculator.
Zero.
Yes. Natural log or log in any base of 1 is always 0. Awesome. We want to look at 56. Any questions on 52? Any questions on 52? Good pick. Okay, so we want to look at 56 now. It was 56, correct?
Yeah.
0 to b m e to negative mx dx. Perfect. Awesome. Good pick. Where do we look? What bothers us? You know that this is not the scientific way, but it's the easiest way to think in terms of this substitution. What bothers you? Not the constant in front and not e, but what really bothers you?
Negative m and x.
Yes. So then we're going to say let u negative mx, as long as du is in the problem or easy to make up.
This is just negative m.
Careful. Du is not the derivative.
And negative m dx.
Exactly. Awesome. So I have the m, I have the dx, I don't have the negative. No problem. I multiply by negative 1 twice. So then I have a negative in front. This and this and this, 1, 2, 3, 1, 2, 3 is in du. What do I do with this?
It will be just e to the u.
Excellent. Careful now. When x is 0, how much is u?
1.
One more time. Negative m times 0.
0.
Good. Now when x is b, what is the upper limit?
Negative MB.
That's it. Good. I'm jumping over all this. What's the next step? There is a minus in front. Which function prime is e to u?
E to U.
E to u. Perfect. Negative outside. I plug in e to negative mb minus. When I plug in 0, that's not 0. When I plug in 0, e to 0 is,
1.
that's it. You can distribute a negative 1, and then you can write it as 1 minus e to negative mb. You can also write it as 1 over e to mb, but this is good enough. Good. So we looked at that. Maybe the adding, I think it's clear. We had examples. Maybe we can go back. Now, areas enclosed, consumer surplus and producer surplus. Maybe this is very clear and we don't need to spend time on it. It's up to you. And differential equations. So this, and this. What do we continue with?
Can we do area enclosed?
Yes. Excellent. So this is my page 6. Yes. They are on page, I think definitely before 4.5. Maybe 4.5. I'm looking, which page? It's there in 4.4, page 425. I'm going to share my screen. 425. Good.